Do you want to train image classification models from scratch or use these models in Flutter with both images and the live camera footage? Then welcome to this course. Image classification is the process of recognizing different entities or things in an image or video. Like you can train an image classification model to recognize animals, plants, diseases, food, activities, colors, things, fictional characters, drinks, and so on. And it has wide range of use cases in mobile applications. Like it can be used for visual search in mobile apps so that user can take a picture of an item and find similar items for sale on web. Similarly, in medical applications, it can be used to diagnose diseases based upon medical images such as X-rays or CT scans. Apart from that, we can use it to build standalone recognition applications like a stone recognition application, a fruit classification application, a dog breed classification application, and so on. And inside this course, you will learn to train your custom image classification models and then use them in Flutter for building powerful Android and iOS applications. So throughout this course, we are going to train different image classification models like a fruit and vegetable classification model, a brain tumor classification model, and a flower recognition model. And then we are going to use these trained models in Flutter with both images and the live camera footage. The complete course is about 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. But one important question is who can take this course? So if you are a beginner Flutter developer or even an experienced Flutter professional, this course has something for you. And the best part is you don't need to have any background knowledge of data science and machine learning to start this course. So what are you waiting for? Join the course now and start building machine learning and computer vision powered applications. So what is image classification? It is a process of recognizing different entities or things in an image or video. Like you can recognize different animals, plants, diseases, food, activities, colors, things, fictional character, drinks, and other such things with the help of an image recognition model. And throughout this course, I will gonna use the terms like image classification, image recognition, and image labeling. And all of these three terms stands for a single thing, which is image classification. And now let's understand image classification with the help of an example. So suppose that we got this image and we want to know that which breed of dog is present in the following image. So to check that, we are going to take an image recognition model which can recognize different breeds of dogs. And we are going to pass this image to our model, and our model will gonna return the result that German Shepherd is present in the following image. So here the main thing is this image recognition model which can recognize different breeds of dogs. So how we can train one such model which can recognize different types of dogs present in images or video? So suppose that we want to train a model to recognize Afghan Hound, German Shepherd, and Pointer. So to train such model, the first step is data collection. And in this step, we collect different images of these dogs which we want to recognize. Like we are going to collect 100 images of Afghan Hound, 100 images of German Shepherd, and 100 images of Pointer. And the process of collecting these images is called Dataset Collection. And after collecting this data, we are going to pass it to our machine learning algorithm. And now this algorithm will gonna find pattern in the images of each type of dog, and our model will be trained. So now after getting this trained model, we are going to pass some image of dog to this model and ask our model that which breed of dog is present in the following image. So if our model is trained well and this algorithm successfully extracted the pattern from these images, then this model will gonna return the result that German Shepherd is present in the following image. But this thing will be possible only if our model is trained well. Because if our model is not trained well, then it will not be able to perform predictions correctly. So now, after training the model and testing it on some sample images, the next step is converting this model into TensorFlow Lite format so that we can use this model inside our mobile application. So that is the whole process of training a custom image classification model for mobile applications. That firstly you are going to collect the dataset on which you are going to train the model, and that dataset will gonna contain images of the items which you want to recognize. So after collecting this dataset, you are going to pass it to the machine learning algorithm and train your model. And after training the model, you are going to test the model and verify that it is working correctly. And then you are going to convert this model into TensorFlow Lite format so that you can use it inside mobile applications. And now let's learn about different use cases of image recognition. Image classification has number of use cases in real world, and we are going to cover few of them inside these couple of minutes. So the first thing where we can use image classification is called product categorization. So in e-commerce applications, image classification can be used to categorize products based upon their visual features. So it is used to organize products into categories for easy browsing. Apart from that, image classification can be used to power visual search in mobile applications. So it means that if you want to search for a particular item, then you can just take a picture of that item and then find similar item for sale on web. Image classification can be used in medical applications to diagnose diseases based upon medical images such as X-rays or CT scans. So basically, we can train image classification models on X-rays or CT scans, and later we can use these models to predict or diagnose different diseases. Apart from above mentioned use cases, we can use image classification to build countless recognition applications for performing number of tasks. Like we can train a model and build application to recognize different breeds of dogs, different types of plants, different species of animal, different kinds of precious stones, and so on. So in short words, image recognition or image classification has a number of use cases in real world. And inside this course, you will learn to train your custom image classification models and then use them inside mobile applications. Welcome to this lecture. In this lecture, we will start the first part of model training process, and that is data collection. Data collection is a process of collecting data for training a machine learning model. And in case of image classification and object detection, this data is in the form of images. So we need to collect images of the items that we want to detect or recognize using our image classification model. And this process is called data collection. There are a number of ways to collect and organize dataset for training your custom model. Like the first one is you can find some existing available dataset and use it for training your model. And the second one is instead of finding an existing dataset, you can write some Python script to collect images from web automatically. And this process is called web scraping. And the third way is to collect the images by yourself one by one. And for that purpose, you can either capture those images or collect them one by one from web. And the fourth way is called data augmentation. So in this method, you take an image of an item and then rotate it or scale it to create new images. So basically, data augmentation is a way to increase number of images inside your dataset so that your model can recognize or detect items at any angle. And now let's look at few things to remember when collecting images for your dataset. And the first one is you should pay attention to the object size. So if you are collecting dataset for training an image classification model, then you should make sure that the images which you are collecting contain the object both in small and larger size. And the reason is, if the object is usually large in the dataset, then your model will gonna perform worse in cases when the same type of object appears smaller. So in simple words, if you are collecting images of apple, then make sure that in some of the images apple appears small, and also in some of the images it appear bigger, so that later when you are going to train your model, the model can recognize apple both in smaller and larger size. Similarly, the second and the most important thing is the number of images inside your dataset. So there should be around 50 to 500 images for each class to get good results while training your model. So if you are training a model to detect or recognize different fruits, then there should be at least 50 images for each type of fruit which you are detecting. Like if you are detecting apple and banana, then there should be at least 50 images for apple and 50 images for banana in your dataset to get good result. And if you are going to increase number of images in your dataset, you will gonna get better results while training your model on that dataset. So these are few things to remember while collecting dataset for training your custom image classification model. And now inside our next lecture, you will learn to collect your first dataset for training your custom image classification model. Hello guys, Hamza here. I just want to let you know that this video is just a first portion of my complete Train Image Classification Models and Build Smart Flutter Applications course. The complete course is about 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. And inside this course, you will learn to train your custom image classification models for Flutter using two different approaches. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 100 students. And now let's continue to the next lecture. Welcome to this lecture. In this lecture, we are going to start the first part of our model training process, and that is dataset collection. And as we are going to train a fruit and vegetable recognition model inside our first section, so we need such dataset which contain images of those fruits and vegetables. So how we are going to get that dataset? So earlier we have learned that we can either collect the dataset by ourselves or we can find an existing dataset. So in this lecture you will learn to find different datasets for training your custom image classification models. So let's start. So the first step is opening your browser and coming to Google. And there you can search for a website named Kaggle. So click on it and you will see these results. So here you can see this first result, which is this for Kaggle.com. So Kaggle is the world's largest data science community with powerful tools and resources to help you achieve your data science related goals. So in this platform, you will gonna find data science related stuff and you will find freely available datasets. So click on it and you will see the home page for Kaggle. And there you can see this home page. And now in the top bar you can see this option for datasets. So you can either click on this datasets or you can click on this search bar and then search for the dataset which you are looking for. Like in our case, we are looking for a dataset related to fruits. So I will gonna type fruits here and then press enter. And there you can see the results, and in the results we got different sections. So we got more than 4,000 different code notebooks, and then we got these comments, datasets, topics and competitions. So as we are looking for datasets, so there are 514 datasets related to fruits. So click on it and you will be able to see the list of datasets here. And there you can see that. So now you can scroll down and select the dataset which you want to use. Like here, we are going to use this fruits and vegetable image recognition dataset. But how you are going to select the dataset which you are going to use? And the simple way is to explore that dataset. Like if we want to see the detail of this dataset, then click on it and it will gonna open the detail page for this dataset. And here you can read the detail about this dataset, that it contains these fruits and these vegetables. So you can look at the name of the items which this dataset contain, and after that, based upon your use case, you can select the dataset. Like here, if you scroll down, you will be able to find the structure of data which is present inside this dataset. So in this side pane, you can see the dataset contains 3 folders. The first one is this test, then this train, and then this validation. And all of these 3 folders contain the images of these items which are mentioned here. And the total size of this dataset is 2.17 GB. And if you want to look at the images present inside each folder, you can simply expand that folder. Like I will gonna expand this train folder, and after that I will gonna expand this apple folder. And if I will gonna select this apple folder here, then you will be able to see the images of apple here. So these are all the images or apple images present inside our dataset. And there you can see there are 3 folders inside this dataset. So basically this train folder contains the images on which we are going to train our model. And this test folder contains the images on which we are going to test our model after training. And this validation folder contains the images which will be used to validate the model training during the training process. So when we are training our model, then this validation dataset will be used to check the model performance when the training is in progress. So that is the mean of these 3 folders. So now after looking at the detail of the dataset, we need to download it. And to do that, you need to click on this download button. But before that, you need to register or sign in on Kaggle. And you can do that by different ways. Like here, I will click on this download button. And then it will gonna ask me to sign in or create our account. So here you can simply attach your Google account and then you will be able to download that dataset. So I will gonna select my account here. And now you can see I am logged in using my account. And after that, if I will click on this download button, you can see the dataset download started. So now let's wait for this download to be completed, and after that we are going to explore this dataset further. So now the download is completed and we got this archive.zip. So let's firstly unzip it and then we are going to explore it further. So now once the extraction is completed, open this archive folder and you will find the same 3 folders here. So this test, train and validation. So as our training data is present inside this train folder, so simply open it and you will be able to find the name of the classes about which this dataset is. So it contains images of apple, banana, beetroot and so on. So here if I will open a particular folder like this apple folder, you will be able to find images of apple here. And same is the case with this banana folder, so let's open it. And you will be able to find banana images here. So now once this dataset is downloaded and extracted, we need to select the classes on which we are going to train our model. Although we can train our model on all of these classes. But for training our first custom image classification model, we are going to select few classes here. Like I am going to select this apple here, then this banana, and after that we are going to select this watermelon, and then we are going to select some vegetables. Like we got onion here, so let's select it. After that select lemon, and then finally we are going to select this potato. And after selecting these classes, let's simply copy them and put them inside a new folder. So I will gonna move back to our archive folder and here create a new folder and name it dataset. And now inside this dataset folder I will gonna paste the classes. And that's it. So there you can see we copied 6 folders from our training folder and we are going to train our model to recognize these fruits and vegetables. So now after separating these folders, if you want to include some more images inside each of the folder, you can simply copy those images from validation or test folder and put them there. And if you want, you can also download some more images of apple, banana, lemon, onion, potato and watermelon and put them inside their respective folder to increase the number of images inside your dataset. And I am saying this because the more number of images which you will gonna have in your dataset, the more accurate your model will be. But for now, after getting these 6 folders, we are simply going to create a zip file for our dataset folder. So here I will gonna right click and then add to archive. After that, create a zip file. And if you are on a Mac, then you can simply compress this folder and get this zip file. So once we got this dataset.zip file, we are ready to train our model on this dataset. Welcome to this section. In this section, you will learn to train your custom image classification model using a platform called Teachable Machine. Teachable Machine is a platform where you can train your custom image classification models without any coding. So by just uploading your dataset on this platform and clicking on few buttons, you will be able to get your custom image classification model. So in this section, we will train our first image classification model using this platform. And for that purpose, we will firstly collect our dataset for training our custom image classification model. And after that, we are going to upload that dataset on this platform. And after uploading the dataset, we will train our model on this dataset by just a single click. And after training the model, we are going to test our model and check its accuracy. And after making sure that our model is trained well, we are going to export our model in a TensorFlow Lite format so that we can use it inside our mobile application. So throughout this section, you will learn to train your first image classification model with just few clicks. So let's begin this exciting section. Welcome to this lecture. So after collecting the dataset, the next step is training our model. And in this approach, we are going to train our model using a platform called Teachable Machine. And by using this platform, we can easily train our image classification model without any coding. So we just need to upload our dataset and then click on few buttons and then we can get our trained model. So now let's start training our model using that particular platform. And to do that, you need to open your browser and here search for Teachable Machine. So there you can see the results, and here the first link is this teachablemachine.withgoogle.com. So click on it and it will gonna open the home page for Teachable Machine. And there you can read the details about this platform, that you can train a computer to recognize your own images, sounds and poses. So with this platform, you cannot just simply train an image classification model, but you can also train sound classification and pose estimation models as well. So here to get started, click on this Get Started button, and then you will see this option that what type of project you want to create. So we got this image project, audio project and pose project. So as we are going to train an image classification model, so we will click on this image project button. And here you will see these options that either you can select this standard image model or embedded image model. So basically this embedded image model is for microcontrollers, and this standard model is for desktop, mobile and web applications. So we are going to select it. And once you will do that, it will gonna create this new project for you. So now here you need to upload your dataset and then click on this train model button, and after that your model will be trained. And after training the model, you can simply convert it and then download it to use it inside your mobile applications. So now the next step is uploading our dataset here. So firstly, open the dataset folder where we got our dataset. So there we put some classes inside this dataset folder. And these classes are apple, banana, lemon, onion, potato and watermelon. So now we need to create classes for each of the items here. So firstly we are going to rename this class to apple. So click apple here, and that's it. After that, in this apple class we need to upload all the apple images, and to do that click on this upload button and then click on this choose images from your files, or simply drag your images here. So what I will gonna do is to open this apple folder and then select all the images, and after selecting it I will simply drag it and put it here. And there you can see, as soon as I dragged it, the images are being loaded here, and you will gonna notice all images will be here in just a second, and there you can see that. So now after uploading apple images we need to do the same for remaining classes. So after apple we got banana, so here I will gonna create a class for banana, and then we will gonna click on this upload button, and after that inside this banana folder select all the images and put them here. So there you can see the banana images are loaded as well. So now after apple and banana we are going to create a class for the next item, and that is this lemon. So to add this class click on this add a class button and then rename it to lemon. And you need to repeat the same process for all the remaining classes. Like after lemon we are going to create a class for onion, and after onion we are going to create one class for watermelon, and finally we are going to create a class for potato, and then we are going to upload the images here as well. So there you can see I created all the classes, and now in this lemon folder we are going to upload lemon images. So here open this folder, then select all the images and put them here, and you need to repeat the same thing for remaining 3 classes. So there you can see we have created and uploaded images in each of the class. So after uploading the dataset to train our model, you need to click on this train model button. But before doing that, you will gonna notice this advanced drop down below that, so click on it and it will gonna show you these options. So basically here we can select few values which will gonna have an impact during training our model. Like you can see this first value is for this epoch, and for now it is set to 50. So this epoch means that during training our model the whole dataset will be passed to the algorithm 50 times, and then we are going to get our trained model. So here you can decrease and increase this number, and after that you can train your model. And after training the model you can test it, and then based upon your model performance you can make changes to the value of this variable. Similarly, the second variable is this batch size. So here for now it is set to 16. So it means that during training our model the images will be passed to the algorithm in a batch of size 16. So basically the images will be passed to the algorithm in groups, and each group will gonna include 16 images. And here you can select different value and check the model result. And then we got this learning rate, so this is just another parameter which is used during model training, and you can try different values for this parameter and check the model results. So these are few parameters which you can train based upon the result of your model and train your model again. But now we are going to use the default values and click on this train model button, and it will gonna start training our model. And as we have set the epoch to 50, so it means that the dataset will be passed to the algorithm 50 times. So you will gonna notice a count starting from 0 to 50. So there you can see this count and it is increasing. And there you can see the count reaches 50 and our model is trained. And once the model is trained, you will gonna notice that this section is expanded, and there you can basically test the performance of your model and then export it or get it in a TensorFlow Lite format. So here to test this model you got 2 options. You can either test it using webcam or using file. So we are going to test our model using file. So select file here, and after that you need to select an image on which you want to test the model. So we are simply going to open our dataset folder, and there I will gonna go to our test folder. So go to test, because this test folder contains the images which are not included in the images on which we trained our model. And here let's test it for watermelon. So I will gonna select this image and simply drag it here. And there you can see once I put it, the image is visible here. And now in the output section you can see the value for watermelon, and it is 100%. So it means that our model thinks that the watermelon is present in the following image, and our model is 100% sure that it's a watermelon. Similarly, let's test it for some other image, like I will select this image. And there you can see the result is same, so it means that our model is trained quite well. Similarly, let's test it for some potato. So I will gonna select this image and simply paste it. And there you can see the prediction is potato and the confidence score is 100%. So it means that our model is trained quite well. Similarly, let's do it for onion. So here let's select this image, and there you can see the result. So now after looking at the result, we can say that our model is trained quite well. And if you are not getting correct results here, then you can make changes in the values of these parameters, or you can increase or decrease the number of images in your dataset and train the model again. And after training the model, you can test it, and then based upon the testing results, you can either export the model or train it again. So now, as in our case, we have verified the performance of our model. So let's click on this export model button, and then you will see the option that in which particular format you want to get your model. Like you can see this TensorFlow.js, which is JavaScript format, and then you got this TensorFlow format, and finally this TensorFlow Lite format. So as we are interested in to use these models inside mobile applications, so we are going to select this TensorFlow Lite option. And then here for TensorFlow Lite you got three options. Firstly, you can select the floating point option, and by doing that you will gonna download a float model which will be more accurate, but its size will be greater. And if you want to reduce the size of the model but you are not concerned about the accuracy, then you can select this quantize option. So basically this quantize means that our model size will be less, but its accuracy will be slightly low as compared to this floating point model. And then this third option is this TPU. So basically this is a tensor processing unit developed by Google, and if you want to run the model on it, then you can select this option. But in our case, we are going to select this floating point option and then click on this download my model button. So firstly, it will gonna convert our model into TensorFlow Lite format, and then it will gonna download our model in the form of zip file. So there you can see the conversion is completed and our model is downloaded. And once it's done, you will find this converted tflite.zip file. So once you will get this zip file, you need to unzip it to look at the model which you trained. Like here I will click on this extract, and now inside this folder we got our model which we trained. So this model underscore unquant.tflite is the model which we trained, and its size is approximately 2 MB. Similarly, this labels.txt contains the name of the items which our model can detect. So we got this apple, banana, lemon, onion, watermelon and potato. So once you are going to download the model and open this label file, here you can simply remove these indexes because later they can cause problem for us. So I will gonna remove this 0, 1, 2, 3, 4 and 5. And after doing that, save the file again and simply close it. So now at this point we have trained our model and then downloaded it in a TF Lite format. And the next step is using this TF Lite model inside our mobile application. Hello guys, Hamza here. I just want to let you know that this video is just a first portion of my complete train image classification models and build smart Flutter applications course. The complete course is about 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. And inside this course you will learn to train your custom image classification models for Flutter using two different approaches. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below and we are offering a discount to first 100 students. And now let's continue to the next lecture. Welcome to this lecture. In this lecture, we are going to look at a platform called Google Colab. So as inside this course, you will learn to train machine learning models for mobile applications. And for training our machine learning models, we are going to use Python programming language. So we need a tool or an IDE where we can run the Python code. So instead of installing any software in your system, we are going to use a very useful tool provided by Google, and with the help of this tool we can run Python code inside our browser. And we don't need to have a powerful system to train advanced machine learning models. So the tool which we are going to use is called Google Colab. So to open it, you need to open your browser and go to Google. And there you can type Google Colab and press enter. And now here you need to click on this link research.google.com Colaboratory. So click on it and the home page for Colab will be opened. So there you can see this page is open. So as I am already using Colab, so I can see this dialog. But if I will click cancel, then you will see this page. So this is the page which you will get if you are using it for the first time. And here at the top right corner, you need to attach your Google account with this platform, otherwise you won't be able to use it. So I currently logged in using my email address. So that is the basic interface of this Google Colab, and here you can run powerful Python code and use all the powerful Python libraries. So here when you will scroll down, you will see the introduction. So Colab or Colaboratory allows you to write and execute Python code in your browser with zero configuration required. Similarly, it provides you the access to the GPUs free of charge, and it also provides you an easy method to share your code. So these are very few advantages of Google Colab, and you will get to know about its benefits once we will proceed in this course. So for now, let's look at some basic operations which we can perform inside this Google Colab. So as we are using it for running our Python code, so here inside this Colab, if you want to run a Python code, you need to create a code cell. So a code cell is similar to this one. So there you can see in this cell, we are declaring a variable with the name seconds in a day. And then we are assigning this value to this variable. And after that, we are printing the value of this variable. So this is a very simple Python code, and we will learn about this syntax inside our upcoming lectures. But for now, you can see these two lines here, and these are present inside a code cell. So if you want to execute this code, you can simply click on this run button, and the code present inside this cell will be executed. So I will click on it. So here for the first time, it will gonna take few seconds to allocate resources to your notebook file. And once done, you will be able to see the RAM and the disk associated with this Colab. And here the execution of this cell is completed and we got this output. Similarly, here you can add more code cells if you want to. Like if I will click on this code plus button, you will see a new cell is added. And here you can write any other Python code. Like I can write a is equal to 5 and then I can print the value of this a. So now let's run it. And there you can see we got the output is equal to 5 here. Similarly, you can add this code cell anywhere inside this notebook file. And after that, apart from these code cells, you can add one more type of cell, which is a text cell. So there you can see, apart from this code cell in this file, we also got these comments. So when you will double click on them, you can see these are also editable, and these are basically the text cells. So you can also add these text cells by clicking on this plus text icon, and a text cell will be added. So you can add as many code cells and as many text cells and easily arrange your code. So that is a basic introduction of Google Colab, that inside it you can write your Python code and execute it without installing any software inside your computer. And now let's see some basic operations which we can perform inside Google Colab. So just like any other IDE or any other code editor, here you can create multiple code files. And a file in Google Colab is called a notebook. So here when you will click on this file button, you will see this option for new notebook, open notebook and upload notebook. Similarly, you can also download or save your notebooks here. So the standard format for storing this notebook or the code file is IPYNB, which is for Python notebook. But you can also save it as a Python file with the extension py. So here let's create a new notebook so that we can see it, and then we are going to download it, and then we are going to open it. So there you can see our new notebook file is created, and here we are going to write a simple code like we can set a is equal to 10 and then we can print the value of a. And now let's run this cell. So there you can see the cell is executed and we got the output is equal to 10. So now you can change the name of this notebook by simply clicking here. So I can name it starter. And after that, if you want to download it, then you can click on this file and then go to download and download it as a notebook file. So there you can see the file is downloaded. And now if you want to open this downloaded file, then let's just firstly close it, and here inside our original notebook click on file and then this upload notebook, and then you can browse to the location where you downloaded it. So I got it here, so I will select it. So there you can see our notebook file is opened. So these are some basic operations which we can perform inside Google Colab. And inside upcoming lectures, we are going to use this Google Colab for training our advanced machine learning models for mobile applications. Welcome to this lecture. So now we have trained our first image classification model using Teachable Machine. And after that we have downloaded that model, and now we got this model in the form of TF-Lite. But you can notice that we got this labels.txt file as well. So basically we got our model and label files separately. But now we want to use this model inside our mobile application. And the approach which we are going to use for integrating this model inside mobile application requires that the model do not have the separate label file, but instead the information of this labels.txt should be attached with this TF-Lite model. So it means that we should have a single file, or we should have a metadata associated with this model. So basically the metadata is a data about data. And in case of this model, if we are going to attach the information like the name of the classes which this model can detect to this TF-Lite model file, then we are going to say that the model have the metadata associated with it. But in case of Teachable Machine, when we download this model, we get these things separately. But now we need to do this thing, or in other words, we need to attach metadata with this TF-Lite model file. And to do that, we are going to run a small Python code. But to run that Python code, we are going to use a platform called Google Colab. So let's firstly learn about a basic introduction of Google Colab, and then we are going to use it for attaching metadata with this TF-Lite model. Welcome to this lecture. So after exploring Google Colab, it's time to use Google Colab for attaching metadata with our TF-Lite model. And to do that, we are going to use a small Python code. and that Python code is present inside a notebook file, and you will find that notebook file in the resources of this lecture. Or you can also check course resources, and there you will gonna find this metadata writer tutorial.notebook file. So basically you need to open this notebook file inside Google Colab. So to do that, click on file and then this upload notebook. And after that I will simply going to drag this notebook file and paste it here. And now in just a minute this notebook file will be opened here. So there you can see this notebook file is opened here, and inside it we got a lot of text but few lines of code. And the main purpose of this notebook is to attach or write metadata with the model. But before doing this thing we need to click on this files pane, and then here we need to upload our model and label file. So you know that we got this model and label file and we downloaded them from Teachable Machine. So now we need to simply drag both of these files and put them here. And once you will do that, you will see this warning, so simply ignore it. And now you can see the label file is uploaded and the model file is also being uploaded. So there you can see the uploading completed, so we got both model and label files here. So after uploading the files here, scroll down and you will see this prerequisite section. So here firstly we need to install this TensorFlow Lite Fortnightly library inside this notebook. And later we are going to use this library for attaching metadata with this TensorFlow Lite model. So simply run this cell. And there you can see the execution of this cell is completed, which means that the library is installed. So after installing the library, you need to import few classes from this library. Like firstly, we are importing this image classifier, and secondly this writer util. So simply run this cell to import these libraries. And there you can see upon running this cell for the first time we got the error. But don't worry, just run it one more time and it will be executed successfully, and there you can see that. And here at this point we are not covering the details about these libraries because later you will gonna learn to train your model using Python code and transfer learning. So before doing that we are going to learn a lot of things about Python. So there we are going to cover these details. But now after importing the libraries you need to skip the next section because there they are importing some example image classification models. But in our case we got our model and label file here. So now in the next section you need to replace the model path with the path of your model. So as we have named our model unquant, so you need to specify the same name here. So model underscore unquant. And after that you need to specify the name of the label file here. So it is simply labels.txt. So change the name here and that's it. And after that you need to specify the name of the resultant model which will be generated, or the model which will gonna have metadata associated with it. So here we are going to name our resultant model as fruits.tflite, and that's it. So after specifying the details, simply run this section and it will gonna create our model file for us. So there you can see immediately the cell is executed and we got this fruits.tflite. So this is the model which has the metadata associated with it, and we have generated this model using this notebook. So after generating it, simply download this model. And there you can see the download started and it will be done in just few seconds. So there you can see the download just completed and we got our fruits.tflite model. So after getting the model, simply copy it at some place safe because later we are going to use this model inside our mobile application. But now in this lecture you have learned that how you can attach a metadata with a model. If you got that model and the label file with you, then you can just simply run this Python code inside Google Colab and attach the metadata with the model and get a model in the form of single file. Welcome to this section. In this section, you will learn to train your custom image classification models using a technique called transfer learning. Transfer learning is a machine learning method where an existing model is reused as a starting point for training a new model. So let's understand transfer learning with the help of this picture. So in the following image, this box is representing the input layer of neural network, and these red boxes are representing the hidden layers or the target model. And then we got this blue box, and it is the output layer. And then this big box, it is representing the model which we are retraining. So if you have took the previous lecture where we have explained the working of neural networks, then you know that for training an image classification model, we need to pass our training images at the input layer. And after that, the value of neurons in the hidden layer is calculated, and finally the value of output is calculated, and that value is considered the predicted value. And after getting this prediction, we compare it with the actual result and update the weights of neural network. But in case of transfer learning, after passing training data at the input layer, we don't calculate the value of neurons in the hidden layer. But firstly, that input will be passed to our source model or the model which we are retraining. And that model will gonna process that input, and after that the value of neurons in the hidden layer is calculated. So that is the difference, that the input which we are passing here will be processed additionally by this particular model, and it has quite a lot of advantages, and you can understand them with the help of this graph. So there you can see on the x-axis we printed training, and on the y-axis we printed performance of the model. And there this solid line is representing model training without transfer learning, and this dotted line is representing model training with transfer learning. And you can notice that when we are using transfer learning, the performance is always greater as compared to when we are not using transfer learning. So there you can see at the start of training, the performance was 0 in case of without transfer learning. But the performance has some value at the start in case of transfer learning. And same is the case with any point of this graph. Like you can see this graph here, the performance is greater if we are using transfer learning, and the performance is lower if we are not using transfer learning. So that is the advantage of transfer learning, that we get better performance as compared to training a model from scratch. So in this section, we are going to train our first image classification model to detect different fruits using transfer learning. And for that purpose, firstly, we are going to collect our dataset, and we have already completed this step. After that, we are going to open our model training code inside Google Colab. And after opening the code, we are going to train our image classification model using transfer learning. And after model training, we are going to test our model to check its accuracy. And then we are going to convert our model into TF Lite format so that we can use it inside our Flutter application. So as this section involves doing a lot of exciting stuff, so let's begin. Welcome to this lecture. So after collecting our dataset and looking at the basic introduction of Google Colab, it's time to train our image classification model on this dataset. And for training this model, we need a Python code using which we are going to train our model. And you will gonna find that code in the resources of this lecture, or you can also find this code in the course resources. So in the course resources, find this model training notebook folder. And inside this folder, you will gonna find this Python notebook file. And we have named it 2024 Training Image Classification Models. So what you need to do is to upload this notebook file inside your Google Colab. So here in my case, I will gonna go to this file and click on this upload notebook. And after that, I will gonna simply drag that file and put it here on this browse button. And now you will gonna notice that our notebook file will be opened here in just a minute. So there you can see our notebook file is opened, and it contains some Python code. And using this code, we are going to load our dataset here and then train our model. And after training the model, we are going to test the model and then convert it into a TF Lite format so that later we can use it inside our mobile applications. And to do that, we need to move to the start of this notebook file. So we are going to run the code present inside this notebook file cell by cell. And I will also provide you the detail about each line of code and its purpose. So now let's start that. So the first step is importing the libraries using which we are going to train our model. So here we are installing two important libraries inside this Google Colab. The first library is this pip library and the second library is this media pipe model maker. So basically in the first line we are installing or upgrading this pip library, and using this library we are going to install other libraries inside this notebook. And after that, using this pip we are installing this media pipe model maker. So this library contains the code for training our model. So let's run this cell, and once we will do that, the resources will be allocated to this notebook and this cell will be executed, and it will gonna take few seconds. So there you can see the resources are allocated and now this cell is being executed. So there you can see the execution of this cell is completed in 38 seconds. So in your case maybe this time is less or more. But once it's completed, then these libraries will be installed inside our Google Colab. And after installing them, we need to import these libraries. So the next cell is about importing these libraries. So there you can see in the next cell from this google.colab, we are importing this files library. And by using this library, we are later going to save our trained model as file. After that, we will import this OS library, which will be used for some operating system related operations. And then we are importing this TensorFlow Lite library as TF. So as we are going to convert our model into TensorFlow Lite format, so that later we can use it inside our mobile applications. So that's why we are importing this TensorFlow library. And after that, we got this line which will gonna make sure that the version of TensorFlow library will be greater than 2. And then from this media pipe model maker, we are importing this image classifier. And using this image classifier, we are going to train our model. And after that, you can see this import matplotlib.pyplot as plt. So basically the use of this library is to plot or show images or draw different graphs. So now to import these libraries, let's click on this run button and these libraries will be imported in just a minute. So there you can see the cell is executed successfully, so it means that the libraries are imported. And after importing the libraries, the next step is loading our dataset. So after importing the libraries, the next thing is loading our dataset. So as you know that we have downloaded our fruits and vegetable dataset, and after that we separated few classes and created this dataset.zip file. So now it's time to use this dataset and train our model on it. So there are two approaches which you can take for uploading your dataset. So one way is to directly upload this dataset.zip file inside your Google Drive. And after that, we are going to connect this Google Colab with the drive. And then we are going to unzip this dataset and train our model on it. And the second way is to directly upload this zip file inside this Google Colab. So there in this Colab, you will find this file section. And there you can upload different files. But I will recommend that you will upload that zip file inside your Google Drive, and I will also explain the reason. But firstly, we need to open our Google Drive so that we can simply upload our dataset. So here inside Chrome, you will find this drive folder. So click on it and your Google Drive will be opened. And if you are using some other browser, simply open the Google Drive for Google account on which you are using this Google Colab. So it's important that you will choose the same Google account here for which you have opened the Google Drive. So once this Google Drive is opened, you can go to this My Drive folder and then you can create a new folder. And you can name this folder with any name that you like. But I will gonna name it as dataset. And after typing the name, click on create and a folder similar to this dataset folder will be created. After that, you need to open this folder and then upload your dataset.zip file here. Like in my case, I have already uploaded it here. But in your case, you need to simply drag this dataset.zip file and then put it here. And it will gonna start uploading your zip file here. And once the uploading is completed, you will get this dataset.zip. And after uploading your dataset here, the next step is connecting your Google Colab with your drive and then accessing that dataset. So to do that, you need to run this first cell, and here from this google.colab we are importing this drive, and after that we are mounting or loading this Google Drive inside this notebook file. So to run this cell, simply click here, and now it will gonna ask the permission to connect to Google Drive so that this notebook can access your Google Drive files. So click on this button and then select the same Google account here. And after doing that, the execution of this cell is completed, and now in the side pane, if you will refresh it, you will be able to see this drive folder. So it means that now inside this notebook file you can access the files available inside your Google Drive. And here when you will expand it, you will find this My Drive, and then inside this My Drive you can access this dataset and then this dataset.zip. Similarly, if you will directly upload your zip file here, then once you will gonna close this notebook and this session will gonna expire, your dataset will be deleted. So it means that the next time you need to upload your zip file here again. So that is the main advantage of using Google Drive, that you will once upload your dataset here and after that you can use it again and again. So now after mounting your Google Drive, the next step is loading and unzipping that zip file. So now after mounting your Google Drive, the next step is loading and unzipping that zip file. So now here you need to specify the path of the zip file, that where you have put it inside your Google Drive. Like in our case, we have put it inside this My Drive folder and then inside a folder which is named as dataset. So I will gonna change this fruit dataset to dataset. And after that we have named our dataset as dataset.zip. So you need to specify the name here. So dataset, and that's it. So you don't need to add zip here. So now here we are specifying the name of the file which contain our dataset, and in our case it is present inside a folder named dataset, and the file is also named as dataset. So carefully specify the correct name here, and then we are using this unzip command to unzip that file. So basically when we will run it, it will gonna unzip that dataset.zip file. So there you can see it is extracting all the images present inside that zip file. And once the execution of this cell is completed, you can refresh this pane and you will be able to find this dataset folder here. And inside this folder you can see the name of the folders which we included inside our dataset. And inside each of the folder the images of that fruit or vegetable is present. And if you will directly put your zip file here, then you don't need to run this cell, because then we are not going to connect with Drive. And after that, to access and unzip that zip file, you need to write this content / and then provide the name of the zip file. So as the name will be dataset, so in that case you will simply going to remove this part. And after doing that, you will gonna run the cell again and it will gonna extract that zip file. But we will stick with the Google Drive approach, so we will gonna undo this thing. So now after loading your dataset, you can simply print some information. Like here you can see in the next cell, we are getting the path of our dataset. So as our dataset is present inside this dataset folder, so you need to access it using this content / and then provide the name of the folder, which is dataset. Similarly, if you have used some other name while creating your dataset folder, then you can specify that name here. So now let's run this cell and this variable will be initialized. And after that, in the next cell, we are printing the name of the classes which we are going to detect or classify. So let's run this cell. And there you can see we are printing watermelon, apple, banana, potato, onion and lemon. So basically here we are extracting our list of labels. And to extract them, we are simply accessing this folder, and then we are putting the names of the folder which are present inside this folder inside this label list, and then we are printing this list here. And after printing the names of the classes here, you will gonna find this next section here, and it contains the code using which we are plotting few of the images here along with the name of item. Like we are going to show an image of apple here, and below that image apple text will be visible. But for some reason this library is not working, so when you will gonna run this cell, you will not be able to see this output. But maybe in your case the problem is resolved and you will be able to see the images here. But that thing is not important. So there you can see the execution of this cell is completed, but we did not see any image. So after running this cell, the next thing is dividing our dataset into training and testing part. So while training our model, we use most of the dataset for training our model. But after training the model, we need to use some dataset for testing the model performance. So here in this cell, firstly we are converting this dataset folder into a dataset object. So using this image classifier .dataset.from folder function, we are creating an object of type dataset. And after converting this folder into this dataset object, we are calling this data.split function and specifying the value here. So basically this split function will gonna divide our dataset into two parts. And here in the first part we are including 90% of the data, and we are naming the first part as training data, and the remaining 0.1% will be used for validation and testing. So basically here we are dividing our dataset into two parts, and based upon this value the parts will be created. So if you will specify the value 0.8, then it means that 80% will be for training and 20% will be saved in this remaining data. After that we are dividing this remaining data using this remaining data.split, and here we are keeping 50% for testing and 50% for validation. So in short words, we are using 90% of the dataset for training, 5% for testing and 5% for validation. And just to remind you that we are training our model on this training dataset. And once the model is trained, then we will test it on a testing dataset to check that how our model will gonna perform on a dataset which is new for our model. And this validation data will be used during model training to check its performance. So now let's run this cell, and it will gonna divide our dataset into three parts. So now after loading our dataset and dividing it into parts, the next step is training our model on that dataset. And after loading the dataset, the next step is model training. But before training our model, we need to select the model which we are going to retrain. Because as you know that we are training our model using transfer learning, and in transfer learning we use some existing model and retrain it on our dataset. So here to select the model which we are going to retrain, we are using this image classifier .supportedModel.fshnnet Lite 2. So basically we are specifying that we are going to retrain this particular model, and the model name is fshnnet Lite 2. Similarly, if you will gonna remove the dot from here and add it again, you will be able to see the list of models which you can retrain. So you can retrain fshnnet Lite 0, 2, 4, MobileNet v2 and MobileNet v2 Keras. So for now we are going to retrain this fshnnet Lite 2 model. So after selecting the model here, the next step is selecting few hyperparameters. So hyperparameters are few variables which affect our model training. So there you can see using this image classifier .hparams, we are creating this hparam object, and here this hparam stands for hyperparameter. So inside this object we are passing few variables. Like firstly you can see we are passing this export directory, and then we are passing the name of the directory here. So basically by specifying this export directory, we are telling that our trained model will be stored in a directory named exported model. Similarly, if you want to use some other name, you can simply specify it. and after that we are specifying the number of epochs. So if you took our previous lectures where we explained the working of neural networks, then you know that the epoch means that how many times the training dataset will be passed to the algorithm and how many times our algorithm will gonna learn from that training data. So for now we are setting it to 50. So this 50 means that during model training, our trained dataset will be passed to the algorithm 50 times. And each time our trained dataset will be passed to the algorithm, our algorithm will gonna extract the pattern from that dataset and our model will be trained. So here, after creating this hparam and spec object, we are creating our image classifier option object. So using this image classifier dot image classifier options, we are creating this object, and inside it we are passing this spotted model, and here we are passing this spec value. So basically we are specifying the model which we are going to retrain here, and secondly we are passing our hyperparameters. So let's run this cell so that our option object will be initialized, and we are going to use this option object below. So now after creating this option object, we need to start training our model. And to do that, we are going to use this image classifier dot create function. And inside this function, we are passing three things. So firstly, we are passing our training data on which our model will be trained. So we are specifying this train data variable here. And secondly, we are passing our validation data, and as I told you that during model training this validation data will be used to validate that whether our model is being trained well or not, and you will understand about it once our model training will gonna start. And after that, the third thing is option object. So we are passing this option object here, and by using this option object, our algorithm will gonna know that which model we need to retrain and where we are going to store our trained model and how many epochs will be during our model training. So now to start training our model, let's simply run this cell, and you will be able to see that our model training will gonna start. So there you can see, firstly it printed this information, and after that it started the first epoch. So here we specified the total epochs to 50, so this count will gonna increase from 1 to 50, or in other words 50 times our dataset will be passed to the algorithm. And at this point, the first time our dataset is being passed to the algorithm and our model is being trained. Similarly, you can see some information printed here. So basically here you can see the information about different layers of neurons which are present inside our neural network. So you can see, firstly we got this Keras layer, and it is representing the model which we are retraining. So there you can see most of the parameters or the variable which we are going to retrain are present inside this Keras layer, and this is representing the model which we are retraining. And after that we got this dropout layer, and it is used to avoid overfitting. And then we got a new layer which we are attaching at the end of neural network. So this is the layer which we are retraining, and the number of parameter or weights present in this layer are 7686, and there you can see the total number of parameters which will be used during our model training. So total parameters are more than 4 million, and out of these parameters only 7686 will be trained, and the remaining parameters belong to the existing model which we are using. And here by these parameters we mean the weight of neural network. So this is some information about our neural network, and here below you can see our model training progress. So right now we are at epoch 5, and here above at the end of each epoch we are getting some information which is quite useful, and it is indicating that whether our model is being trained well or not. Like there you can see at the end of first epoch we are getting the value for loss, accuracy, validation loss, and validation accuracy. So if you have took the previous lectures where we have learned about this loss function, then you know that this loss is indicating the difference between predicted value and the actual value. So basically, when we are passing input to the model and the model predict a value, then we calculate the difference between predicted value and the actual value, and that difference is indicated using this loss function. So if during our model training the value of loss function is decreasing, then it means that our model is being trained well. So there you can see at the start the loss function was 1.85, and after that its value is decreased and it is 1.69 now. Similarly, it is decreasing there. And after that you can notice we got this validation loss here. So this is the loss calculated using the validation data. So at the end of each epoch, we are passing our validation dataset to our trained model, and then we are calculating the validation loss and validation accuracy. And here, to check that whether our model is being trained well or not, the value for this validation loss should also decrease. So there you can see it is decreasing starting from first epoch till the second epoch. So it means that our model is being trained well. And the second parameter to check that whether our model is being trained well or not is the accuracy. So here we got the simple accuracy which is for our training data, but the actual indication of our model accuracy is using this validation accuracy. So at the end of first epoch, our validation accuracy was 0.20. So it means that if we are going to pass 100 images to our model, it only returned correct prediction for 20 images. But at the end of second epoch, our accuracy increased to 58%, and then it increased to 79, 83, and now it is 87%. So it means that at the end of 7th epoch, our algorithm extracted enough pattern from our dataset that now when we are going to pass 100 images to our model, it will gonna predict 87 images correctly. And at the end of the 50th epoch, you will gonna notice that we will gonna have validation accuracy above 95%. So it means that our algorithm will gonna extract the pattern from our dataset and our model will be trained at the end of 50th epoch. But for now, to summarize the thing, during our model training, the loss and the accuracy is indicating that whether your model is being trained well or not. So if the value for loss and the validation loss is decreasing, or the value for accuracy and the validation accuracy is increasing, then our model is being trained well. So now let's wait for our model training to be completed, and then we are going to analyze the results. So now the epoch reaches 50, so it means that our model training is completed. And there you can see at the end of our model training the validation accuracy is 1.0. So it means that it is 100%. So in other words, when we pass validation dataset to our trained model, it returned the correct prediction for all the images. Similarly, you can see the value for this validation loss and it is quite low. And same is the case with this normal loss and accuracy, that the loss is decreasing here and the accuracy is increasing. So based upon this validation accuracy, we can say that our model is trained quite well. But after training the model, the actual way to check the model performance or accuracy is testing it on our testing dataset. And to do that, we are using this model.evaluate function here. And then inside it, we are passing this test data object. And we created this object here and it contains our testing dataset. So now it means that the test dataset contains the images which we never used with this model for training. So now to test our model, we need to execute this model.evaluate and it will gonna return us the loss and the accuracy. And then we are printing these values here. So let's run this cell. So there you can see the execution of this cell is completed and we got the value for test loss and test accuracy here. So the value for test accuracy is 0.916. So it means that our model returned correct prediction for 91% of the images. Similarly, you can see the value of loss and it is quite low. So it means that our model is trained quite well. Although we can increase the accuracy of this model by retraining it on a dataset which contains some more images, then you will be able to see much more accuracy here. But still, as a first attempt, we got a quite well trained model here. And now after testing the model, the next step is converting our model. And to do that, you need to run this model.export model function, and it will gonna export or convert our model into TensorFlow Lite format. So here let's run this cell. So after the execution of this cell, you can refresh this side pane, and then inside this exported model folder, you will be able to see our model in a TF-Lite format. So there you can see this model.tflite file. So this is the model which we trained, and now it is in a TF-Lite format. And after doing that, you can simply download this model by clicking on these three dots and then selecting this download button. Or you can also download it using this next cell. So here we are simply calling this files.download function, and then we are downloading this particular file. So basically we are passing path of the file which we want to download. So here let's run this cell, and there you will be able to see downloading model.tflite. So this download will be completed in few seconds. So there you can see the execution is completed, and we got our model here in the form of TF-Lite. So once the model is downloaded, you can simply copy it and put it inside a separate folder, because later we are going to use this model inside our mobile application. But now at this point we have trained our custom image classification model, and then we tested the model, and after that we converted that model into TF-Lite format. Similarly, you can make changes in the dataset, like you can add some more images in the dataset and then train our model again, and after that check the results. Welcome to mobile application development section of this course. As we have trained our custom image classification models on our custom datasets, and we have converted those models into TensorFlow Lite format. So now it's time to use these models inside Flutter and build smart Flutter applications for both Android and iOS. So in this part you will learn to use image classification models in Flutter with both images and the live camera footage. So firstly you will learn to use image classification model with images. So in this part you will firstly learn to choose images from gallery or capture images using camera inside Flutter. And after that you will learn to pass these images to image labeling model of Google MLKit library and get the prediction. And finally you will learn to use your custom trained image classification models in Flutter with the images from gallery or camera. After that you will learn to use your custom trained image classification models with the live camera footage. So in this part you will firstly learn to display the live camera footage in Flutter. And after that you will learn to pass the frames of the live camera footage to image labeling model and get the prediction in real time. And finally you will learn to use your custom trained image classification models in Flutter with the live camera footage. So at the end of this section you will have skills to use image classification models in Flutter with both images and the live camera footage. So let's start. Welcome to this lecture. In this lecture, we are going to build our first Flutter application of this course, and this is an image picker application. So basically, we are going to build an application where user can choose an image from gallery, or he can capture an image using camera inside our Flutter application. And after that, we are going to display that selected or captured image inside our Flutter application. And we are building this application because later we need to pass that image to our machine learning models and get the results. So that's why we are learning to choose or capture images inside Flutter. So now let's start by creating a new Flutter project. So open your Android Studio and click on this new Flutter project button. After that, make sure that Flutter is selected here, then click next. And here you need to assign a name to your application. So I will name it as image picker. And after that you can select the project location here, and then you can add a description if you want to. And after that you can select the platforms for which you want to build this application. Like here, Android, iOS, Linux, Mac, Web and Windows is selected. So it means that this Flutter project will be created for all of these platforms. So after ensuring these things, click on this create button and our new Flutter project will be created in just a second. So now our new Flutter project is created and it is ready. So let's firstly install this new application inside an iOS simulator or inside an Android emulator and look at the default counter application. And after that we are going to start building our image picker application. So I have already created an iOS simulator and you can see it here. And in your case, if it is not running, then you can click on this open iOS simulator. Then a simulator similar to this one will be opened. And after that you can select it here and then click on this run button and our application will be installed inside it in just a minute. So now our application is installed inside the simulator and you can see the starter application. So this is basically the default counter application provided by Flutter. And here when you will click on this floating button, this count will gonna increase. So this is the application present inside our starter code. And now we are going to make changes inside this code because we want to build our image picker application. And the first step of building our application is creating its GUI. So inside our image picker application, we are going to add a button on screen. And when the user will gonna click on this button, we are going to launch the gallery where user can select an image. And once user will gonna select the image, we are going to display that selected image here. Similarly, when the user will gonna long press on that button, we are going to launch the camera. And when the user will gonna capture the image in that camera, we are going to display the captured image here. So that will be the flow of our application. And now we are going to start by adding the GUI of our image picker application. So in the GUI, we will have a button and then a view where we are going to display the image. So where in this application code we need to add the button. So right now you can see we are inside our main dot and it contains all the code of this counter application. So here when you will scroll down, you will find a build method here. And inside this build method, the GUI of this application is present. So when you will scroll down, you will gonna find this text widget which is displaying this text. You have pushed the button this many times. So this is the text which is being displayed here. And then also we are displaying this count here. So here we are displaying the GUI of this counter application. But now we want to build the GUI of our image picker application. So we are going to remove the GUI of this counter application here. So basically inside our build method, we got a scaffold. And then in that scaffold, we are displaying this app bar. And this app bar is displaying this title, Flutter Demo Homepage. And after that, in the body of this scaffold, we are displaying a column widget. And that column widget is displaying both of these text widgets. But now we are going to remove both text widgets from here. And after that, press Command S. And when you will do that, you can see this text is gone. And the reason is we have removed these widgets from here. Similarly, let's remove this button as well. So you can see this floating action button. So just select it till this point and then remove it. After that, press Command S. And now you can see this button is gone as well. And now after removing the previous GUI, we are going to add an elevated button here. And then in that button, we are going to pass the child property. So the child of this button will be a text widget because we want to display a text choose or capture on this button. So write the text choose or capture. And after that, the second thing which we need to pass is this onPress method. So this callback or this method will be executed when the user will gonna click on this button. So here we can pass an empty method. And this method will be executed once the user will gonna click on this button. So press Command S. And you can see this button choose or capture. And when the user will gonna click on it, this method will be executed. And inside it, we are going to write the code for opening the gallery so that user can select an image. And once user will gonna select the image, we need to display that image above this button. So to display that image, we are going to add an image widget inside our GUI. So write image here and then call its file method. So we are going to display the image using a file object. And the reason is, once we are going to choose or capture the image, we are going to get that image in the form of file. And after that, we are going to display that image using this image.file method. But right now, we do not have our image in the form of file format. But later, we are going to get that image in the form of file. So to store that image in a file object, what we can do is to create a file object inside our my home page state. So basically above this build method, you can declare a variable of type file and then you can name it image. And after that, you need to import the library in which this file object is present. So click on this icon and import this library .io. And after that, you will see an error here because we did not initialize this image object. So here we can make this image object nullable. So it means that this image variable can be null or it can contain an image file. So after creating this image variable here, we are going to pass it inside this file object. So image and select this image. And after that, between these two widgets, add a comma and this error will be gone. But right now you can see we are getting an error that this image can be null or the argument of file cannot be assigned to a parameter of file. So basically it is stating that we cannot specify this image variable here because it can be null. So here, to avoid this thing, we can check that if this image variable is null, so in that case we are not going to call this image.file function. So if this image is equal to null, so in that case we are not going to do this thing, but in that case we are going to display an image icon here. So I have added an icon widget here, and inside it you can specify the icon which you want to display, and you can select this icon using this icons class. So add this icons and then add a dot and you will be able to see a lot of icons here. So as we want to display an image related icon, so type image and you will find a lot of image icons. So let's select this icon for now, and after that add a colon here because this is the else block. And after doing this thing, we have made sure that whenever this image variable will be null, so in that case we are not going to display the image but we are going to display the icon. So here we can pass a not null insertion that this image variable will not be null whenever this function will be called, because we have made sure that whenever this variable is null we are going to display an icon and not going to display this image. So after doing that, press Command S and there you can see this small image icon here. And now we can also increase the size of this icon. So here set the size property and we are going to select the size to 50 for now. After that, press Command S and you can see the size of this icon is increased. Similarly, if you want to increase it further like 150, then you can do that and you can see its size is increasing. So now we have created a very simple GUI for our image picker application, and in that GUI we have added a button which is displaying this text choose or capture, and then we are displaying a view or a widget where we are going to display the image. So basically before displaying the image we are checking the value of this image variable. So if it is null, so in that case we are going to display this icon here, and if it is not null, which means that user have chosen or selected any image, so in that case we are going to display that image on screen. And now inside our next lecture we are going to start the process of choosing or capturing image inside our application. So see you in the next lecture. Hello guys, Hamza here. I just want to let you know that this video is just a first portion of my complete train image classification models and build smart Flutter applications course. The complete course is about 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. And inside this course you will learn to train your custom image classification models for Flutter using two different approaches. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 100 students. And now let's continue to the next lecture. Welcome to this lecture. So now after creating the GUI of this application, it's time to add the feature of choosing or capturing images inside Flutter. So to do that, we are going to use a library called Image Picker. So open your favorite browser and then go to Google, and here type pub.dev, and you can also directly type it here in the search bar. And now in the search result, open this first link pub.dev, and this website will be opened. So this is basically the official package repository for Dot and Flutter applications, and here you can search for any Dot or Flutter related library, and the library which we are looking for is called Image Picker. So type Image Picker here and press enter. And after that, to view the results clearly, let's minimize the simulator, and you will be able to see this Image Picker library as the first result, and it is the most popular and used library in Flutter. So click on this library and the documentation page will be opened. And now the first step is installing this library inside our Flutter project. So to do that, click on this installing section, and there you will find this dependency. So just simply copy this line and open our application, and here inside pubspec.yaml file you need to paste this line in the dependencies section. So you can see this section here, and whatever library you want to add in your project, you need to paste its dependency here. So I pasted it here, and now click on this pubget, and this library will be downloaded and added inside our project in just a minute. And there you can see this library is downloaded and it is now added inside our Flutter project. And after adding the library, open the documentation page again and go to README section. And there we will find the instructions for using this library inside iOS and Android. And you can also see we can use this library inside macOS, web, Windows and Linux as well. So here scroll down, and the first section which you are going to find is for iOS. So basically, to use this library inside our iOS applications, we need to follow these steps. And if we want to use this library inside Android, then we need to follow these instructions as well. So these are some additional things which we need to do for Android and iOS. So we are firstly going to start by looking at the instructions for iOS. So as the main purpose of this library is to open the gallery so that user can select an image. And similarly, it also provides an option to launch the camera so that user can capture an image. So for using this library, we need to add few permissions inside our application. So basically we are going to show user a dialog that our application want to access the gallery or the camera. And if user will gonna allow those permissions, only then this library will gonna help us to choose or capture images inside Flutter. So to add those permissions, we need to add some key string pairs inside our iOS section. So basically when you will gonna open the Flutter project, you will find this iOS folder. And when you will expand it, you will find this runner folder, so expand it. And inside it, you will find this info.plist file. So now inside this file, we need to specify the reason that why our application want to access the gallery or camera. And we are going to specify that reason in the form of this key string pair. So between these key pairs, we need to specify the key that for which permission we are writing the reason in the string tag. So here when you will open the documentation page, the first tag is this NS photo library usage description. And here we need to specify the reason that why our application want to access this photo library. So just simply copy this key and open our application. And here inside this dictionary tag, add a new key tag. And after that, paste the line that we copied, and then create a closing key tag as well. So here we have specified this key, and now to write the reason you are going to add a string tag here, and after that create a closing string tag as well. And now between these string tags you need to write the reason that why your application want to access the gallery, and this reason will be according to your application. Like if you are building an image editing application, then you can write the reason as my application provides the functionality to edit images, so that's why we need to access the gallery. So here you can type that reason, and after that we need to do the same thing for the camera as well. So what you can do is to copy this key string tag, and then you can paste it here, and after that improve the spacing, and then open the documentation page and copy this NS camera usage description, and after that open our application again, and here in the key tag simply replace the key with this key. So now here you will going to write the reason that why your application want to access the camera. And similarly, if inside your application you want to record a video, then you need to specify the reason that why your application want to access the microphone as well. So that's how inside iOS section you are going to specify the permissions. So after following these steps, the setup for iOS is completed. And now the next instructions are for Android. So for Android, no configuration required. So as this library is updated, so now we don't need to do anything inside Android section. And by just simply installing this library inside our Flutter project, we can use it inside Android applications as well. So after doing that, the setup for both Android and iOS is completed. And now the next step is using this library for choosing or capturing images inside Flutter. So now after setting up the library, let's start using it for choosing or capturing images. So on this documentation page, scroll down and you will find this example section, and there you will gonna find the instructions for using this library inside Flutter. So you can see the first step is creating an image picker object, and after that to pick an image they are calling this picker.pickImage method, and inside it they are specifying the source to gallery. So basically if you want to select the image from gallery, then specify the source to gallery here, and if you want to capture an image using camera, then specify the source to camera here. So now let's start using this library so that things will be clear. So first step is creating this image picker object. So open our application and go to main ... and here we can remove these comments to make our code cleaner. Similarly, let's remove all of these comments as well. And after doing that, to format our code, right click or press Ctrl click and select this reformat code with dot format, and it will gonna format our code, and it is looking much better. So now let's enhance this section, and then above our build method we are going to declare an image picker object. So let's call this object as image picker, and after that add a late keyword before this declaration because we want to declare it later. So after declaring the object here, we are going to initialize it inside our init state method. So here type init and you will see this option for init state. So just select it and this method will be added. So this init state method is the first method which will be called once our application will be visible on screen, and inside it we are going to initialize this image picker. So write image picker and then call its constructor, so image picker, and that's it. So now we are declaring our image picker object here and initializing it inside our init state. And after doing that, we need to use this image picker for choosing or capturing image. So to do that, we are going to create a method and name it choosEmage. And we are going to call this method when we want to choose an image from gallery. And as we want to choose the image when the user will gonna click on this button, so we are going to call this method inside this onPress. So call this choosEmage method here. and that's it. So now when the user will gonna click on this button, this choose image method will be executed, and inside it we are going to write the code for launching the gallery and choosing the image. So to do that we are going to use this image picker and we are going to call its pick image method, and inside it we need to specify the image source. So type image source and then add a dot, and you will see these two sources here. So as we want to choose image from gallery, so we will select gallery here, and that's it. So this line will gonna open the gallery once user will gonna click on this button, and then user can select the image, and once user will gonna select it, this pick image will gonna return an X file object. So here we can create an X file object, and then we can name it selected image, and after that we can assign the result here. And as this X file is nullable, so add a question mark here, and after that we need to add an await keyword here. And we have added this await keyword here because this pick image method will gonna open the gallery, and until user will gonna select the image we are not going to get this X file. So basically we need to wait here. So that's why we added this keyword, and once we will do that we need to make the method asynchronous inside which we are calling this await keyword. So make this method asynchronous, and that's it. So it means that this method will be executed asynchronously, and meanwhile other things can be performed in the backend. So now this choose image method will be called, and inside it we are calling this pick image, and it will gonna show a gallery here. And once user will gonna select the image, we are going to get that image in the form of X file object. And after getting the image we need to display that image to the user on screen. And to do that we need to store this X file inside our file variable, because when this image variable will not be null, then this image will be displayed on screen using this image.file. So here to convert this X file into a file object, you can firstly check that if the selected image is null or not, because there are chances that it will be null because it is nullable. So if it is not null, so in that case we are going to assign the result to our image variable, and here we are going to create a new file object, and inside it we are going to pass the path of the file, and we are going to get the path using our selected image. So selected image dot path, and after that add a semicolon, and that's it. So basically if the user have selected the image, then this code will be executed, and we are going to store that selected image in the form of file object inside our image variable. And now as this image variable will not be null and it is containing an image, so our image will be displayed here instead of this icon. But to tell our GUI that this image variable is changed, we need to call setState method, and inside it pass the variable about which you want to inform the GUI, and that's it. So now as this image variable will not be null, and because of this setState our GUI will be updated, so we will be able to see the selected image here. So after making all of these changes, simply click on the stop main dot and then install the application again inside the simulator, and now you will be able to choose images inside our Flutter application. Similarly, you can install it inside an Android emulator and you can perform the same thing there. And here you can notice that we clicked on this stop main dot and then install the application again, and the reason is we have added the image picker library, and now to make those changes in the installed application we need to install it completely. So now our application is installed, so let's click on this button. And there you can see when I clicked on it, I got this pop-up that our application would like to access your photos. And the reason mentioned here is the word which we put inside our info.playlist. So there you can see we did not write any proper reason. We just wrote the word reason. So whatever text you will gonna write here, it will be visible. So here let's give this permission, and once I did that, I will be able to see the gallery of my iPhone, and same will be the case for Android. And here we can select any image, like I am going to select this image, and as soon as I selected the image, our image is being displayed in the GUI. And the reason for this thing is, once user have selected the image, we got that image in the form of X file object, and then we converted it into a file object and told our GUI that this image variable is updated. And now in the GUI we are checking the value of this image variable. So if it is not null, then we are going to display the image using this image widget. Similarly, you can try the same thing for some other image. So I will gonna select this image, and you can see our image is being displayed here. So now the first feature of our image picker application is working correctly. And now after choosing the image, the next step is capturing the images using camera inside our application. So to do that, what we need to do is to add another callback inside this elevated button. So basically we want that when the user will gonna long press on this button, we want to open the camera so that user can capture an image. So inside our elevated button, after this on press, we can add an on long press method, and then we can create the body of this method. And now inside these brackets we can call another method which is capture image. And we did not created this method yet, but now above we are going to create this method below this choose image. So simply copy this choose image method and paste it below, and here rename it to capture image. And after doing that, inside this method we need to make only one change, and that is, instead of this image source to gallery, we need to specify the image source to camera here, and that's it. So now when the user will gonna long press on this method, then this capture image method will be called, and inside it we are using this image picker.pick image method, but this time this pick image will gonna launch the camera, and once user will gonna capture the image, we are showing that image to the user on screen. But if you will try to run the application on iOS simulator, you will not going to get anything upon long pressing on this button, because there is no camera preview inside iOS simulator. So to test this feature, we need to install the application inside an Android emulator. So to test this feature, I am going to install this application on an Android emulator. So I will gonna select this Pixel 8 emulator here, and in your case you can select the one which you created. And after that, let's simply click on this run main ... and our application will be installed inside that emulator in just a minute. So now the application is installed inside this Android emulator, and because of the settings of my system, you can see this warning. So I can click on wait and this will be gone, but in your case it will not gonna occur. So to open the camera, what we can do is to long press on this choose or capture button. And there you can see the camera is opened inside this Android emulator, and this is the default camera preview for this emulator. So let's capture an image. And once I captured the image, you can see this captured image is being displayed inside our application. And same is the case for real device, that when you are going to install this application inside your real iOS or Android device, you will be able to choose or capture images inside your application. And we are doing that with the help of this image picker package. Welcome to this lecture. So now we have completed our image picker application in Flutter, and in this application we are choosing images from gallery or capturing them using camera inside Flutter. And in this lecture we will quickly review the process that how we have built this application. So firstly, we have created a new Flutter project, and then in that project we have added this image picker library, and using this library we are able to choose or capture images inside Flutter. And after adding the library, we have specified the permissions for iOS inside our info.plist file. And after doing that, inside our main ... we have declared an image picker object, and then we initialized it inside our init set. After that, in the GUI, we have added this elevated button, and when the user is clicking on it, we are calling this choose image method, and when the user is long pressing on it, we are calling this capture image method. And inside these methods, we are using this image picker library to choose or capture images. So here, once user will gonna capture the image or he will gonna choose it, we are going to get that image in the form of X file object, and after that we are converting it into a file object, and then we are storing it inside this image variable, and we are using this image variable in the GUI to display the image. So there you can see we are checking the value of this image variable, that if it is not null, then we are going to display the image stored inside this variable. So that is the reason that once user will gonna choose or capture the image, the selected image is being displayed here. Welcome to this lecture. In this lecture, we are going to start building our image labeling application in Flutter. And in this application, we are going to perform image labeling using images. So let's start. So the first step of building this application is getting the starter application code from GitHub. And this starter application code is exactly the same application which we have built inside our previous section, where we have learned to choose or capture images inside Flutter. So we are going to take the code of that application as a starting point. So if you already got it, then you can simply open it, or you don't have it, then you can take this starter application code from GitHub. So you can check this lecture resources and you will find the link of this repository, or you can also type it manually here. And once this repository page is open, click on this code button and copy this link. After that, open your Android Studio and here click on these three dots. Then click on this get project from version control, and here you need to paste the link. And after that, make sure that the Git is selected here. And then you need to choose the location where you want to clone this repository. And after choosing it, you can click on this clone button and our project will be cloned and opened in just a minute. So click on trust project. And now this starter application code is opened here. And here, when you will expand this lib folder and open this main dot, you will be able to see the same code which we have written for our image picker application. And here, firstly, we need to click on this get dependency so that the libraries will be downloaded and these errors will be gone. And there you can see all of these errors are gone. And now let's firstly install this application inside an Android emulator or inside an iOS simulator to confirm that it is the same application. So I already got this iPhone 14 Pro Max, so I will gonna select it, and after that run the application inside it. So now the application is installed inside the simulator and you can see it is the same application which we have built inside our previous section. So here, upon clicking on this button, user can choose an image from galleries. So let's select this one. And there you can see our selected image is being displayed here. Similarly, upon long press, he can capture the image and then that captured image will be visible here. But in case of simulator, there is no camera, so we cannot test that thing. So now after getting this starter application, it's time to build our image labeling application. Hello guys, Hamza here. I just want to let you know that this video is just a first portion of my complete train image classification models and build smart Flutter applications course. The complete course is about 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. And inside this course, you will learn to train your custom image classification models for Flutter using two different approaches. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below and we are offering a discount to first 100 students. And now let's continue to the next lecture. So now after importing the starter application, the next step is building our image labeling functionality. So to add image labeling inside this Flutter application, we are going to use another library. So what you need to do is to open pub.dev inside your favorite browser, and here you need to search for Google MLKit image labeling. So Google MLKit image labeling. After that, press enter. And there you can see this first result, Google MLKit image labeling. So this is the library which we are going to use for performing image labeling inside our Flutter application. So just click on it and the documentation page for this library will be opened. And here the first step is installing this library inside our Flutter application. And here you will find the instructions for using this library inside our Flutter application. But if you want to learn more about the features of Google MLKit image labeling library, then you need to explore this link. So I will gonna open this link inside another tab, and it will gonna open the detail about the features of this library. So here you can read about the introduction of this library, the key capabilities, and also other things. So the main thing is, by using this library we can perform image classification inside our mobile applications. And the library provides us a base model which can recognize up to 400 different categories. But apart from that, you can also train your own custom model and then use it inside mobile application using this library. Similarly, when you will scroll down, you will find the detail about the base model that it can recognize up to 400 different items, and also find the detail that you can also use your custom TensorFlow Lite model and use it inside mobile application using this library. And we are going to do both of these things inside this course. So firstly, we are going to use their base model inside our Flutter application, and later we are also going to train our custom TensorFlow Lite models and use them inside Flutter applications for performing image labeling. Similarly, you will also find the list of 400 different items which the base model can recognize, and you can also explore this page further by yourself. But we are going to move to the documentation of the Flutter library. So here the first step is installing this library inside our application. So I move to the installing section, and here we are going to copy the dependency. So simply copy this dependency and open our application. And here inside our pubspec.yaml file, simply paste it below this image picker. After that, click on this pubget so that the library will be downloaded and added inside our project. And there you can see the library is downloaded and it is added inside our application. After that, open the documentation page and go to readme section. And there you will find the instructions for using this library inside both Android and iOS for performing image labeling. So when you will scroll down, you will find this requirement section. So here firstly we got some requirements for iOS, and then we got some requirements for Android to use this library. So if we want to use this library inside iOS applications, then we should check these things, or in other words, these conditions must be fulfilled. So here the first step is our minimum iOS deployment target should be 12. So to confirm this thing, open the project, and here you will find this iOS folder, and it contains the native code for iOS. So you can simply click on it and then press command click. And after that, in the Flutter section, you will find this option, open iOS module in Xcode. So just select it, and it will gonna open this iOS section inside Xcode. And there we are going to make sure that these requirements are met. And there you can see our iOS module is opened inside Xcode, and it will gonna take some time for processing. But once done, this project will be ready. So now here we need to make sure that our minimum iOS deployment target should be 12. So click on runner, and there you will find this option minimum deployment, and you can see 12 is already selected. So if in your case it is selected less than 12, then make sure that 12 or greater than 12 is selected here. Similarly, click on runner here, and you will find this option here as well. So make sure that it is 12 or greater than 12. After that, click on runner test, and there you will also going to find it. Similarly, click on this pods, and there click on this pods, and you will find this option here as well. So in short words, you need to click on every option, and wherever you will find this drop down, make sure that 12 is selected. Like I will gonna select this one, which is for image picker, and after that go to general, and you will find this minimum deployment. Similarly, for this image picker iOS, you will also going to find it that it is 12 here. And then we are going to click on this pod runner and pod runner test. So you can see that everywhere 12 or greater than 12 is selected. So it means that the first requirement is met. And after that, the second requirement is our Xcode version should be greater than 13.2.1. So open the Xcode, and here click on this Xcode and then select about Xcode, and you can see my version is 14.2, which is greater than 13.2.1. Similarly, you can check your version and it should be greater than that. So the second requirement is also met. And after that, the third requirement is our Swift version should be 5. So to confirm this thing, open the terminal. And here you need to type this command xcrun swift version. So after typing it, press enter, and there you can see my Swift version is 5.7.2. So it means that the third requirement is also fulfilled. And then the fourth requirement is MLKit does not support 32-bit architecture. So MLKit does support 64-bit architecture. So you can check this list and see if your device has required device capabilities or not. So you can check this list and find your device there. But this requirement is mostly met for all the systems. And after that, we need to do one final thing, and that is we need to go to project, runner, building settings, excluded architecture, and there we need to make sure that the architecture selected is ARMv7. So open Xcode, and here go to runner, and after that click on runner here, and then go to build settings, and here you will find the option of excluded architecture. So you will find it here, and if you cannot, then you can search for it here, and once you will find it, expand it, and inside it we got this debug, profile and release. So here we need to click on this plus icon for debug, and then type ARMv7, and we need to repeat the same thing for profile and release. So click on this plus icon and then type ARMv7, and finally for release, so ARMv7, and that's it. So now after following these steps, the setup for iOS is completed. And to confirm this thing, open our application inside Android Studio and click on this top main dot. And after that, install the application again inside this iOS simulator, and if it installs successfully, then it means that the library is successfully added and set up for iOS. And there you can see our application is installed again inside the simulator, so it means that the library is set up successfully. And if while running it inside iOS simulator you are getting any error, then you can open the terminal here and try to run this command flutter build iOS. And once the build is done, then you can try to install the application again inside the simulator, and it will gonna work. So after following these steps, the setup for iOS is completed, and now the next setup is for Android. So in order to use this library inside Android, we need to make sure that our minimum SDK version should be 21 and our target and compile SDK versions should be 33. And to confirm these things, open the application, and here you will find this Android folder. So just expand it and then expand this app folder, and here you will find this build.gradle file. So just open it, and inside it search for minimum SDK version. So there you can see this property min SDK version. So you should manually set it to 21 or greater. Similarly, the second thing which you need to set is the compile and target SDK version. So our target SDK version should be 33, so I will gonna change it to 33 here. And then our compile SDK version should also be 33. So here let's add 33, and that's it. So now after following these steps, the setup for Android is also completed. And now we can use this library inside our Flutter application. So now after doing the setup for both Android and iOS, we are ready to use this library inside our Flutter application. So at this point inside our application, user can choose or capture the image, and after that we are displaying that image here. And now we need to pass that image to our image labeling model, and that model will gonna return the list of items present in that image, and then we are going to show those results here. So to do that, inside our application code, we need to create another method. So below this choose image or capture image method, we are going to create another method, and we are going to call it perform image labeling. And after that, inside this method, we are going to pass this image to our image labeling model and get the result. So we are going to call this method inside this capture image. So call this perform image labeling method here. And also here inside our choose image. So perform image labeling. And that's it. So now once user will gonna choose or capture the image after displaying the image here or getting the image in the form of file, we are calling this method. And inside this method, we need to pass that image to our image labeling model. So to do that, open the documentation page and scroll down. And there you can see here the first step is converting our image or creating an instance of input image. So in image labeling, we want to pass an image to our image labeling model and get the result. But we cannot pass that image directly to our image labeling model. We firstly need to convert that image into a format called input image, and then we can pass this input image to our image labeling model. So now we need to convert this file image or image in a file format into that input image format. And to do that, on this documentation page, you will find this link. So create an instance of input image as explained here. So I will gonna open it inside another tab. And there you will find the instructions for creating an input image object from different formats. Like if you got the path of image, then you can convert it into input image using this input image.from file path function. And if you got your image in the form of file, then you can use this input image.from file function. So in our case, we are going to use this function because we got our image in the form of file. And if you got your image in the form of bytes, then you can use this function. So in our case, we are going to use this one. So what you can do is to open the application, and inside perform image labeling, we are going to declare an input image object. So input image, and then we are going to name it as input image. And after that, to convert our image or our file into input image, we are going to call this input image dot from file function. And inside it, we are going to pass our image file. So pass image file here. And after that, we need to add not null insertion. And we are going to add this insertion because we are 100% sure that this image variable will not be null once this line will be executed. So here add a semicolon, and that's it. So now when this line will be executed, our selected or captured image will be converted into this input image format. And now we can pass this input image to our image labeling model. And to do that, open the documentation page, and there you can see the second step is creating our image labeler. So basically we need to load our image labeling model so that we can pass our input image to that model and get the output. And to do that, you will find the instructions here. So what we can do is to simply copy them, and then inside our application we are going to paste them inside our init state. So here below this image picker, simply paste it, and now let's look at them. So now here we have created and initialized our image labeler object, and once this line is executed, the base model of MLKit library will be loaded, and now we can pass input image to the model and get the output. But inside this image labeler, we have specified this parameter image labeler options, and the role of this object is to customize the working of our model. So by using this object, we can customize or control few things of our model. Like inside this image labeler option, there is one parameter called confidence threshold. And this parameter is actually a double value and its range is between 0 and 1. And to understand the role of this variable, we need to understand the working of our image labeling model. So basically, when we are passing an image to our image labeling model, the model tries to recognize the item, and after recognizing it, the model is assigning a value to each recognized item, and that value is actually the confidence score. So if our model is more sure or certain about a certain item, then the confidence value will be close to 1. And if our model is not sure about a certain item, then the value will be close to 0. So here, by setting the value of this confidence threshold, we can control that which items should be included in the result or not. Like here, if we set this value to 0.6, then it means that when we are going to pass an image to our model, and the model will gonna return the predictions or the results, then in that results only those items will be returned for which the confidence score is greater than or equal to 0.6. Similarly, if we change it to 0.7, then it means that only those results will be returned for which the confidence score is greater than equal to 0.7 or 70%. So we are going to choose a value like 0.6 here, and that's it. So in short, when this line will be executed, our image labeling model will be loaded. And now we can pass this input image to our image labeling model and get the result. And to do that, open the documentation page and you can see this third section. So here we are using this image labeler object and calling its process image method. And inside it, we are passing our image in the form of input image. So when this line will be executed, our image will be passed to our image labeling model and the model will gonna return the result. And those results will be in the form of this list of image label. So let's simply copy this code and we are going to explore it further after pasting it. And we are going to paste this code inside our perform image labeling. So below this input image, simply paste it. And after that, as the name of our image labeler is labeler, so we are going to change image labeler to labeler. And after that, we need to make this method asynchronous, and that's it. So now here, when the image will be passed to the model, we will get the result, which is this list of image label. And inside this list, each image label object is representing an item which our model returned. So if we passed an image where a football, a chair and a person is present, then this list should gonna contain 3 image label objects, and one image label object will be for chair, one will be for football, and the third one will be for person. So here we are using a for loop and iterating this list. So for each image label which is present inside this list, this loop will be executed, and now we can get the name of the recognized item using this label.label property, and then we are storing it inside this text variable. And after that, we can get this label.index, which is actually returning an index assigned to that particular predicted item. And then the third thing is the confidence. So this label.confidence will gonna return a double value, and it is representing that how much our model is sure about particular prediction. And as here we have specified the confidence threshold to 0.6, so inside this list there will not be any object for which the confidence will be less than 0.6. So now here, after getting the items, we can simply print the results in the console to get the idea about the working of this application. So here, for now, we are going to print the name of the recognized item. Similarly, if you want, you can also print the confidence score. So here we are going to add some spacing and then print the confidence as well. So confidence, and then call toString method. And after that, add a semicolon, and that's it. So now we can simply run this application and then choose or capture an image. And once we are going to do that, this perform image labeling method will be executed, and inside it we are going to pass that image to our image labeling model and get the result. And after that we are iterating this list and printing the results in the console. So let's click on this run main dot dot, and after that we are going to test this application. So now our application is installed again, so let's choose an image from gallery. So I will gonna choose this image, and there you can see our image is being displayed here. And now let's go to the run section, and there you can see we got some results here. So the first result is this flower part, and it is also relevant with this picture, although it is not present here, but the plants are present. Similarly, the second prediction is plant, which is present inside this picture. And then we got the third prediction, which is vegetable. So as it was not a complete picture, but still we are getting correct predictions here. Similarly, let's select some other image. Like we are going to select the complete picture now. And there you can see we got the similar results here, but this time the confidence scores are higher. So for flower part, the confidence score is 0.94. So it means that our model is 94% sure that flower part is present inside this picture. Similarly, let's select some other image. So we are going to select this particular image where beach is present. And there you can see once I selected the image, I got some more results here. So now here the first result is beach, and for it we got a confidence score of 0.99. So it means that our model is 99% sure that beach is present in the following picture. Similarly, the second prediction is sky, and then we got sand, vacation, event, layer. So all of these predictions are quite relevant to the picture which we selected. So it means that our application is working correctly and we are able to get the predictions from the model. And now we need to show these predictions on screen to the user. So now after getting the results from the model, we need to show them to the user on screen. And to do that, inside our build method, we are going to add a text widget after this elevated button. So here add a text widget, and now inside this text widget we need to pass those results. So to pass those results, we are going to create a string variable outside of this perform image labeling. So string, and we are going to name it as results, and inside this variable we are going to store an empty string. And after that, inside this loop, we are going to assign the name and the confidence score for each prediction to this string variable. So here we can simply concatenate the value of this variable. And firstly, we are going to show the name of the predicted item. And after that, we are going to add few spaces. And then if you want, you can show the confidence score. So confidence. And here, as the confidence is a double value, so we can trim it. And to do that, we can call this toString as fixed. And here you can specify the number of fraction digits. So if you only want to get 2 fraction digits, then you can specify 2. And after that, we can add a new line character at the end so that the next prediction or the next result will be shown on a new line. And that's it. So now when this loop will be executed, the name and the confidence score for each predicted item will be stored inside this results variable. And then we can simply pass this results variable here so that these results will be visible on screen. But to actually make them visible, we need to do one more thing, and that is we need to call setStateBlock after this for loop and pass this results variable here. And by doing this, wherever we are using this results variable, the changes will apply, or we will be able to see the results here. Similarly, inside this perform image labeling, we need to reset the value of this result variable for each new image. Otherwise, the value will be concatenated and we will not be able to see the result for each image separately. So here by doing that, whenever user will gonna select a new picture, the previous results will be removed from this variable. And after doing that, there is only one final thing which is left, and that is enclosing this column widget inside a single child scroll view. And the reason for this thing is sometimes the results will be longer, so we will get an overflow error. So here we can make this column scrollable by enclosing it inside a single child scroll view. So click on this column and then press Alt plus Enter, and here select Wrap with Widget, and now type single child scroll view, and that's it. So after making these changes, click on this run main dot, and then we are going to test the application again. So now our application is refreshed, so let's select the same image. So I am going to select this image, and there you can see once I selected the image, now below this button we got the result, which is beach, sky, sand, vacation, event, and so on. Similarly, let's choose some other image, like I will choose this waterfall, and there you can see we got the result: waterfall, rock, mountain, aircraft, and river. So it means that our application is working correctly and we are able to get the results from our image labeling model. And now inside our next lecture, we will work on the GUI of this application and make it prettier. And after that, we are also going to perform image labeling in Flutter with the live camera footage. But for now, we have completed our image labeling application, and inside it, we are performing image labeling with images. Hello guys, Hamza here. I just want to let you know that this video is just a first portion of my complete train image classification models and build smart Flutter applications course. The complete course is about 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. And inside this course you will learn to train your custom image classification models for Flutter using 2 different approaches. Apart from that, you will get a certificate upon completion which you can add to your resume, and the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 100 students. And now let's continue to the next lecture. So now let's quickly review the process that how we are performing image labeling in Flutter with images. So to do that, we have firstly added the library inside our pubspec.yaml file. So there you can see this dependency Google MLKit image labeling. And after that, we followed some steps for iOS and Android to make sure that we can use this library inside both Android and iOS. And after doing that, the next step was loading our model. So we created an image labeler object here, and then inside our init state we initialize that object. And by initializing it, the default model of MLKit image labeling library will be loaded. And now we can pass an input image to that model and get the output. And for choosing or getting the images, we are using the image picker library. So each time when the user will gonna choose image or capture it, after getting the image in the form of file object, we are calling this perform image labeling method. And inside this method, we are converting that image into that input image format. And after that, we are passing that input image to our image labeling model by calling this labeler.processImage. And this method will gonna pass our image to the image labeling model, and we will get the results in the form of this list of image label. After that, we are iterating this list, and for each recognized item, we are getting its name and the confidence score and storing it inside this results variable. And we are displaying the value of this results variable in the GUI. So once user will gonna choose or capture the image and we will get the results from the model, we are displaying those results here. So that's how image labeling is being performed inside this application. Welcome to this lecture. In this lecture, we will work on the GUI of our image labeling with images application. So right now the GUI is quite basic, but now we are going to beautify things. So in this lecture, we are not going to do anything technical or about machine learning. So this will be just about GUI. And if you want to skip it and proceed to the next section where we are going to perform image labeling with the live camera footage, then you can do that. So now let's start. So the first thing is we need to improve the visibility of this image. Like here, for now we are simply displaying it in the center. So now to improve the look of this image, we are firstly going to set the size, and to do that we are going to enclose this image widget inside a container. Or what we can do is to enclose the entire code inside a container. So here we are going to add a container, and now let's set the child property, and there we can simply cut this code and then paste it here. And after doing that, press Command S and you will not going to notice any change in the view. And after that, let's improve the formatting. So press Ctrl click and reformat code with dot format, and it is looking better. And after doing this, let's set the width and the height of this image widget or this particular view. So for now, we are going to set the width equal to the width of the device. And to do that, we are going to set the width property, and to get the device width, we are going to use media query class. So media query dot of context. And then to get the size of the device, we will get this size object, and then to get the width, we will get this width property. So this will basically going to return the width of the device on which we are running the application. And after that, we can set the height, and for now we are going to set the height equal to the half of the height of the device. So media query dot of context dot size dot height divided by 2. And by doing this, we are saying that the height of our image widget or this particular view will be equal to the half of screen. And after doing that, press Command S. And now you can see a spacing is added here because the height of this view is increased. And after doing that, let's add a shadow to the image. And to do that, we are going to enclose this container inside a card widget. So wrap with widget, and then add this card. And after doing that, press Command S. And there you can see now the image is enclosed inside this card widget, and a shadow is added. Similarly, the default color of card is added as well. So here, if you want, you can specify your custom color. Like here, we are going to select the gray color. So colors.gray, and then press Command S. And there you can see gray color is added here, and now the image is looking better. Similarly, if you want to add the margin or spacing between the edges and this card view, then you can set the margin property. So margin, and then we are going to select edgeInsets.all, and we are going to set a margin of 10. So now press Command S. So there you can see the view is separated and it is looking much better. So now after improving the look of this image, we are going to work on the GUI of this button. So right now, for choosing or capturing image, user is either clicking on it or long pressing on this button. But now instead of that, we are going to add two separate buttons for camera and gallery. So here above our elevated button, what you can do is to add another card widget, and then in that card widget we are going to add a container, and we are going to set a height property of this container to 100. So this container will be for showing the button for choosing or capturing image. So after doing that, add a comma after this card and then press Command S. And there you can see this container is added. Similarly here we can set the margin. So edgeInsets.all, and we will choose a margin of 10. And after that, if you want, you can also set the background color. So let's set it. So color, and we are going to choose a different color here. Like one interesting color is this lime accent. So just select it and press Command S. And there you can see this container is added. Similarly here you can select different shades of this color. Like we are going to choose this shade 400 and then press Command S. and now you can see this shade is applied and it is looking better. So now after adding this box inside it, we are going to display two buttons. One will be for choosing image from gallery and the second one will be for capturing image. So inside our container we are going to set the child property and the child will be a row widget. And now inside this row we are going to add multiple icons or buttons. So I have added the children property for our row. And now inside the children's, firstly we are going to add a button or a view for choosing images from gallery. So firstly we are going to add an icon widget and there we are going to display an image related icon. So search for image and after that press Command S. And there you can see this image icon is added, and although it is very small, so let's set its size. So size, and we are going to select 50 here. After that press Command S, and now it is looking better. And now to make this icon clickable, we are going to enclose it inside an inkwell widget. So click on it and press Alt plus Enter and then wrap with widget. And here we are going to select an inkwell widget. And when we wrap a widget with this inkwell widget, it provides us few methods like this on tab, on double tab, on long press and so on. So it make that child clickable. So here inside our inkwell we are going to set this on tab method because we want to detect when the user is clicking on this icon. So when the user will gonna click on this icon, we are going to launch the gallery. So here add this on tab method, and now in the body of this method we are going to call this choose image method because this is the method which we are calling when the user is clicking on this button. So now after doing that press Command S and then click on this image icon. And you can notice that the gallery is open, so we are not going to choose any image here. So now after adding this icon for this gallery, we are going to add an icon for the camera as well. So what you can do is to format the code, and after that you can copy this inkwell widget and then you can paste it below this inkwell. So paste it here. And now let's change this image icon to a camera icon. So search for camera and you will find a lot of icons. So we are going to select this one. And after that, when the user will gonna click on this camera icon, we are going to call this capture image method. So just call it and then press Command S. And there you can see the camera icon is added as well. But right now both icons are quite close to each other. So what we can do is to set the main axis alignment property for our row widget. So main axis alignment and then add a dot and you will find these options. So right now we want to equally position them, so we can select this space evenly. But if you want to center them, then select center. And if you want to add maximum space between them, then select this space between. But right now we are going to select this one, and after that press Command S. And there you can see both of these icons are equally positioned, and right now they both are functional, which means that if you are running it on an Android emulator, then you can also click on this icon and then the camera will be opened. And after that, for the captured image, you will be able to see the results here. So now after doing that, we can simply remove this elevated button because we don't need it. After that, press Command S and now you can see the button is gone. So now after doing that, two views of our applications are completed, which is this image view and this buttons view. And now we need to improve the visibility of this bottom view. But before doing that, let's work on our app bar a little. So there you can see we got our app bar here. So there we are displaying this title Flutter demo homepage. So instead of that, we can display the title of our application. Like we can write recognizer, or you can type anything which you like. And after doing that, press Command S and now you can see the text is changed. Similarly here we can change the background color of the app bar. So we are going to choose the same lime color. So colors dot lime accent dot shade 400. After that, press Command S. And now you can see this application is much better because this color and this color is similar. And now we need to work on the GUI of this bottom box where we are displaying the results. So to make our results look better, we are going to enclose this text widget inside a card widget. So click on this text and then Alt plus enter, and after that wrap with widget. And the widget which we are going to use is a card widget, so just select it and press Command S. And there you can see a box is added in the background. So now we want to increase the width of this view so that it can cover the width of screen. So we are going to enclose this text widget with a container. So select wrap with container, and then we are going to set the width property of this container. So here we are going to set width equal to the width of screen, and we are going to get the width using our media query. So media query dot of context dot size, and then move it to a new line and add a dot, and you will see this width. So just select it and press Command S, and now you can see the width is increased. Similarly, let's improve the formatting, and after that let's set the margin property for our card widget. As we are using a margin of 10 on all the widgets, so we are going to select datasets.all and then add a margin of 10 here. Now press Command S, and there you can see an equal margin is added here, and it is looking better. Similarly, to separate this text from the walls of this card view, we are going to set the padding property for our container. So here let's again format the code, and then we are going to set the padding property for our container. So padding, and we are going to choose a padding of 10 on all sides. So agentsets.all, and then add 10 here and press Command S, and there you can see this padding is added here. So now after making these changes, let's increase the size of text. So inside text widget, set the style property. So we are going to choose this text style object, and inside it we are going to set font size, and there we can select the font size like 24 and press Command S. And there you can see the size is increased and it is looking better. Similarly, let's change the color of this container or card widget. So we are going to select the black color here. So colors.black. And after that, we are going to change the text color to white. So here, select this color property for the font and choose colors.white. And then press Command S. And that's it. So now you can see our application is looking much better because we have some consistency. So this box is matching with the app bar, and these icons are matching with the bottom box. So overall our application is looking much better. Similarly, you can add or enhance the GUI of this application further as per your needs. And then you can also share the picture with me in the question and answer section or in the messages section. Welcome to this lecture. So after using image labeling feature of MLKit inside our Flutter application, it's time to use our custom trained image classification models inside Flutter. So for that purpose, we are going to start the process. And while taking this lecture, you can see something is different here. And that thing is, earlier we were recording this course on a Mac operating system, but now we have a Windows operating system. And that is only because of some technical reasons. So if you are on a Mac, then you can still follow this course. So now I have opened the same application which we completed inside our image labeling with images section. So in this application, user can either choose images from gallery or capture them using camera. And after that, we are passing this image to our image labeling model and showing the result here. And if you did not have the code of this application, then you can check the resources of this lecture, or you can take the complete code from this GitHub repository. So you can open your browser and type this URL, and after that you can download this code or clone it. Similarly, you can check the resources of this lecture and you will find this application code. And now inside this application, we are going to use our own trained image classification model. And to do that, you need to open the documentation page of the library which we are using. And here, when you will scroll down, you will find this section, Load Custom Model. So there you will find the instructions that how you can add your custom TF Lite model and then use it with image labeling library. So to add your custom TF Lite model, you need to firstly place it inside your project. And to do that, here inside your project, you need to create an asset folder. So what you can do is to right click on this image labeling folder and then create a new directory. And we can name this directory as assets. So after typing the name, press enter and this directory will be created. And now inside this directory, let's create another directory and name it ML. So press enter and this directory will be created. And here it is not necessary to create this ML directory, but you can still paste your model inside this assets folder. But it is a good practice that inside assets we are going to put machine learning related stuff inside this ML folder. So now after creating this folder, you need to put your model inside this ML folder. So what you can do is to open the folder where you got your trained model. Like in my case, I got my fruits.tflite model here, and we have trained this model using Teachable Machine. And later we are also going to use our transfer learning trained model here inside this application. So for now, what you can do is to simply copy this model and add it inside this ML folder. Similarly, if you do not have this model, you can check this lecture resources and you will find this TF-Lite file here. But for now, you can see this TF-Lite model is added. So now after adding the model inside your pubspec, you need to declare this ML folder and you will gonna declare it in the bottom. So there you can see in the Flutter section, we got this code commented. So what you need to do is to select these 3 lines and then uncomment them. And here be very careful with the spaces. So we need to remove 1 space from here and this error will be resolved. Similarly, we can remove the second line because we don't need it. And after that, remove 1 space from the first line and now we are good to go. So basically here we are defining this assets portion and then we need to define the folders which we are using inside our application. And the folder which we are going to use is this assets ML. So here you are going to specify this assets and then the name of the ML folder. After that, add a / and that's it. So basically here we are declaring that our application can access the files present inside this ML folder. Similarly, if you name this folder something else, then you need to specify that name here. So now after doing that, we have added this model successfully inside our application. Hello guys, Hamza here. I just want to let you know that this video is just a first portion of my complete train image classification models and build smart Flutter applications course. The complete course is about 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. And inside this course, you will learn to train your custom image classification models for Flutter using 2 different approaches. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below and we are offering a discount to first 100 students. And now let's continue to the next lecture.